Math 103, Chapter 9, Estimating a Population Proportions. What we discuss here is, let's say there is a large city and you understand that 40% of people in this city are willing to vote. So we show this with capital P, okay? And let's assume we don't know that, we don't have this 40%. So what we do is we take a sample from different areas of the cities. For instance, we take a sample from one section, ask like 600 people here. And based on that 600, we create an interval that, okay, 32 to 45% are willing to vote. We show that P hat because we are taking a sample. Then we take another sample, okay? We take another sample and that has to be 600 again and should be equal. And then we measure and we understand that the interval of people who vote is, I don't know, just let's say is 42 and 37. Then we take another one. We take so many samples and we create all these intervals. 95% of these intervals have this 40% in it, like these. Let's say you pick another one, and P is less than 38 and greater than 25. You understand, for this one, 40 does not fall. So this one is not good, right? So 95% of the samples, when you take one, like here I take 1, 2, 3, 4, 5. Let's say you take so many samples and you find average of all these samples and you create a confidence interval. That confidence interval that you create, it has this 40 in it. So all the samples that you're taking, they all are P hat, which is the sample. And 95% of these would, 95% of all these, except like this one, they all have this population in. And that's what we are discussing here. We don't know the original population. We want to find it by statistic. How do I find it? We take the equal samples and find the proportion for all these samples. So then we discuss here, they call it estimate. So the first step is to estimating a population characteristics such as population proportion or population mean, they call it. So they call this population proportion or population, the capital one, the original one. Is to select appropriate sample statistic when the goal is to estimate population proportions. You know, you see the numbers are kind of small, but I think these are coming from your textbook, so you could actually find these pages and read it. What is important is this. When you take all these samples, they are consistent that they are not overestimate or underestimate the value of the populations. A statistic that does not consistently tend to underestimate or overestimate the value is said unbiased estimate. You see all these that we took in the beginning, and they all have these, they are unbiased because they all have this 40 in it. You see 40 is between these two numbers. 40 is between these two, but not that one, right? So unbiased are the ones who actually have the population proportions. And then when you take all the samples, let's say if the population or proportion is 40, some of the samples, when you take it, the interval are very close to this, like this two. But this one is not. If the 40% is here, majority of the samples are here. So this is not a good samples. And it explained. The sampling distribution in figure 9.1a is for a statistic that is not likely to result estimate close to the population. These kind of samples are kind of further away from the population. So they don't give you really a good number to be close to that, but the other two are. Now, here, when you take the samples and you actually want to find the proportion of population, you have to do some calculation. What I did was here, let me show you something here. I summarize here in these 2 pages a couple of definitions that we are going to use there. See, the original formula is this. When you finally come up with an interval, this is a proportion of the population, and this is proportion of the samples. This E, they call it margin of the error, okay? To understand this better, let's think of this example. Let's say you go to a company and you get a job and you want to know the salary for particular positions. Let's say your position is like engineer 1, and you want to know what is the salary for these particular positions. The guy in human resources, they tell you, well, the salary is $38,000 plus or minus $4,000. What does that mean? That means some people, the salary is what? 42,000, or salary could be 34,000, right? Plus or minus means the actual salary here is 38,000 plus 4,000 is always between these 2 numbers, and 38,000 minus 4,000. So the range of the salary is always between these 2, which is what? 34,000 and 42,000. So when they tell you the proportion is between these 2 numbers, then you get the idea that your salary must be between these 2. So if you want to propose a salary, or if you want to ask them for a salary, make sure your salary falls between these 2 numbers. This 4,000, they call it margin of error. And that's what we need to calculate in these sections. So the formula is sample proportion plus E, sample proportion minus E. What is E? E, they call it margin of error, and is equal to 1.96 radical P times 1 minus P over N. So margin of error is the whole thing here. This is margin of the error. If the margin of error is large, if N value is large, then that indicates that you don't have very accurate information. If this N is small, then this number would increase. So you get a big number here. You don't want that. You always want a small number, right? So here, if margin of error is small, if the N value is getting lower. So if N is getting larger, then the margin drop. And as I show you here, that the N value increase if you have dealing with a large number. Like when you take a sample, instead of 2,000, let's say take 3,000, 4,000. The larger the sample, the less your error is. The error or margin of error is less, okay? So when I hear, if you want to reduce this, then you just say the salary is between 38,000 plus $200 and 38,000 minus 200. It just exaggerated, but that shows that this number is small. So you feel comfortable that, oh, your salary is probably around 38,000. Okay, so the smaller the margin of error, the better it is when you're estimating. So that's what they have here. This part, just this radical, they call it a standard error. Where did we get 1.96? This is a Z value that I'll show you in a minute on the next page or so, okay? There are 2 conditions for you to use this formula. One is you take the value of N and multiply by P, and that has to be greater than 10, and N times 1 minus P also has to be greater than 10 to two conditions need to be met. One is when you take a sample, it has to be a random sample. Okay, you randomly select some people. You don't go to a particular area that you already know people are going to vote there. You don't do that. You randomly select numbers. In some of the problem, if population is given, then you use that one here. But if population, a proportion of population is not given, then you could use p hat. So in the problem, you either have proportion of population, you could use that to find the margin of error, or you use proportion of this sample to use the margin of error, okay? Now, these p hat tend to produce more accurate estimate if the population is far from 0.5 or 50%, okay? What does that mean? Let's say you go to a place and you know that nobody is in this city is going to vote, 0%. So you know this proportion of the sample that you're taking definitely is close to the proportion of the population. Or you go to an area of the city that you know almost every single person in that area would vote, or 100%, or 1. So in that case, when you take a sample, you know this sample is equal to proportion of populations. But if the number is getting close to half, then when you take the samples, numbers are not as close as to the proportional population as you go further to 1 and 0. So sample p hat tend to produce more accurate estimate if you are further from 0.5, if you get to the other side, okay? So now this is a good example here. It's the author of the paper is estimated all criminal cases heard by Supreme Court. And in 11 states, they figured that from 2000 to 2004, of the 1,488 cases considered, 391 were decided in favor of defendants. So what is the proportion of populations? Proportion of population, they measure from 2000 to 2004. Their measurement shows that proportion of population is 391 out of 1488. This is proportion of populations, right? And so this P is population proportion because all cases were considered. You did all the cases here. Now, suppose population proportion is this, was not known. Let's say you don't know about this number. You want to find a number that is close to this. So in that case, you have to take the samples, okay? So you plan to select 25 of 1488 cases. So you go to the court and you go through the files, and out of 1,488 cases, you select 25 of them and you calculate your P. This is P hat, or proportion of the samples, okay? Now, a standard error is always equal to P times 1 minus P over N. So this is a standard error, okay? Remember this part. This part, which is radical P times 1 minus P over N, we call it a standard error. So when we calculate a standard error, we came up with these numbers. Okay, so in practice, the value of P is not given. Obviously, the P that in this case is given, normally you don't know that. That's why you're trying to take a sample and find that. But if you increase your sample from 20, see how we take 25 cases out of 1488? Why don't you take more folders out of that? Take 100, then you get a smaller error, say 0.44 instead of 0.88. So in this formula, the larger N, the less error you have. So it's always better to take a large number instead of 25 cases or 25 folders you pull out. Why don't you take like 100 of them? That's what they're talking about here. And then in section 9.2, they're saying that, okay, so from now, remember, when you take all the samples, mean of proportion is always equal to mean of populations. Means what you're trying to do is you're trying to find the proportion of the sample which is equal to proportion of population, this close to each other, mean. And this part we said is the standard deviation. Now, I took this page from the other textbook from Maria Traiola, 6 editions. Here is a good example. They are saying that, okay, they took so many samples. For each sample, let's say from one area of the town, they took 200 samples and they calculate the interval. This is the interval. Then they took another sample to calculate the interval. You see all this interval except this one, they all have 0.5. Let's assume that we are trying to find proportion of population for one city, and we know proportions of population is 0.50. Let's assume it's unknown, but we know it's about 50%, right? When you take all these samples and you create your interval, when you create your interval, then you notice that 95% of sample interval contain this 0.50. See, they all contain this 0.50, except this one. So 95% of the samples that you are taking normally contain proportion of populations, okay? And that 95%, it gives you 1.96. See here? This area is 0.95. If I calculate the Z for this, alpha, so here, 95%, if you subtract that from 1, that gives you 5%. 5% is area of these two tails. If you divide that by 2, the area of each tail is 0.025. If you use your calculator and want to find the Z for area of 0.025, then that Z is 1.96. And that's the number that we normally use in the problems here. You see, this 1.96 is coming from here. This area is 95%, so area of each tail is that. And the best way to find this, if you don't want to use the table on your calculator, go to second vars, and then inverse norm, and then put the area, 0.025. When you enter, the calculator will give you 1.96, positive or negative, it doesn't matter. That's where the 1.96 come from. Is the Z value for this area, which normally you could use it through the TI-30 or TI-84 calculator. Okay, so here, if you just have this part, this is the standard error. When you multiply by 1.96, when you take the radical and multiply by 1.96, then that would give you the E. So just the radical, they call it a standard error. When you take the radical and multiply by 1.96, then that gives you margin of error here. So margin of error, which normally we show with letter E, margin of error is when you take 1.96 and multiply by this radical. This radical, they call it standard error. Some calculation instead of 1.96, they round it to 2. That also is correct. So if you ask you to find margin of error, all you need to do is calculate this radical and then multiply by 2. And then if you want to know the confidence interval for proportion of populations, you put it between these two. And these are some examples here. So always there are, if you want to use the formula, there are two conditions, NP and N times 1 minus P must be greater than 10. Your sample must be random and large. So basically we are using this formula for all the problems. Look at in these examples. In this example, you have P hat is given, okay? So you put that p hat here, 0.43, 1 minus 43, and how many samples you take? 1,000 times 1.9. That gives you the margin of the error. Okay. These examples are all very, very similar. So when you calculate, first you calculate NP and N times 1 minus P to make sure both of them are greater than 10. And then margin of error is this again. So section 9.1 is very easy to answer the problems here. You know, like here, they're saying which one shall be picked. Always a large number is better. When you take a sample, don't take just 70, take 400, take a large one. This one is very similar to that example. You know, if this is the actual populations, see, this one is very far from here, from this number. The good one is this. And also this one. These two are very close to PR population. So this example, you could follow those. And then that brings to 9.2. Basically, all the problems in 9.2 are very, very similar. What we do, like in this one, they are taking a random sample of 600 customers, include 510 who indicated they were satisfied. 510 out of 600. That, if you divide, that gives you the proportion of the sample. Proportion of the sample is 510 out of 600. And then they ask us to find a standard error. Remember the formula? P times 1 minus P. And then they ask you to find margin of error. All I need to do is take this and multiply it by 1.96. These problems are all very, very similar here. I'll show you the calculation here so you can figure this out. Make sure you always meet those conditions if you want to use the formula. Conditions are you take the value of n, multiply by p, and value of n, 1 minus p, okay? Which here, in this problem, since proportion of population is not given, you could always use proportion of the sample when you do the calculation. So here, I can put like that here, okay? You have to use one of these two. One is always given in the problems. So 1.96 times p times 1 minus p over n is given in this problem. See, they all are very, very similar. This one, they're telling you that if you want to use the formula, you always want to make sure that n times p and n times 1 minus p are greater than 10. All these examples, they have great, except this one. If one of the two does not meet, then that violates the condition. So that's why this one is not good, because this is 9 and it's less than 10. If one of the two is not good, then that would violate the rule, okay? That sample size is not good, not large enough. Okay, so that would be end of section 9.1 and 9.2.